Hello friends, welcome to yet another module on cross-sectional and longitudinal studies. Cross-sectional research is a type of research in which we examine one variable in different groups of people that are similar in all other characteristics. Here, the research design is a design in which we examine a question. For example, let us look at the research question on: does the percentage of women diagnosed with breast cancer increase with age? So here you want to know whether women who are older have breast cancer. So in this research design, we would take three groups of women who are similar in various aspects but different only in their age group. So you can take women in a particular community in the reproductive age, and you can carry out this investigation. The different age groups may be, for example, 20 to 35 years, 36 to 50 years, and 51 to 65 years. So here you have three groups of women. And what is the variable? You want to know whether they have breast cancer. So in your study, you would collect data on whether women have breast cancer or not. So finally, you can calculate the percentage of women with breast cancer in each age group. So this will enable you to answer your question. So what was your question? You wanted to know whether women with increasing age have breast cancer. So in this study, you can find out the prevalence of breast cancer in the three groups of women and find out whether older women have a greater prevalence of breast cancer compared with the younger age group. So having understood this cross-sectional study design, let us look at the characteristics of this cross-sectional design. A cross-sectional study is based on observations that take place in different groups of people at one time. That is, you have observed three groups of women in different age groups, but at only one point of time to find out whether they have breast cancer or not. Here, there is no experimental procedure involved. No variables are manipulated by the researcher. You simply record the information, describe the characteristics that exist in a group. This cannot be used to determine any relationship that may exist. The information may then be used to develop a hypothesis. Having understood how to design the study, let's go into the details. Now, when designing a cross-sectional study, you must first choose a representative sample. That is, after having chosen the research problem, you must choose on whom you are going to conduct the study. The people on whom you will be conducting the study must be matched in several aspects. Like, for example, they may be of the same age group, from the same socio-economic status, or from the same cultural background, having the same food habits, and so on. This is very important because if you conduct a study on a heterogeneous group, a group of different age groups, or maybe of different gender, or different cultural or food habits, then your study results may not be true. So, a representative sample is very important in a cross-sectional study. The next thing that you must look into is the sample size, because the sample size must permit you to carry out some statistical analysis. In statistics, you have two types of sample size: a small sample size and a large sample size. So, depending upon your need, you must choose a sample size that will permit you to carry out statistical analysis. The third thing that you should look into is data collection. How you are going to collect the data. Data collection is very important because data must be valid, must be reliable, it must be accurate. So, you must adopt various techniques required for data collection. Fourth thing that you should look into is how you're going to express the results of your study. You must finally determine the prevalence, the incidence, or the count of a particular disease or factor in your population. There are two types of cross-sectional studies. One, the descriptive cross-sectional study, and two, the analytical cross-sectional study. In the descriptive cross-sectional study, you may be used to assess the frequency and distribution of a particular disease in a defined population. For example, a random sample of schools across Tamil Nadu may be used to assess the burden or prevalence of asthma among 12 to 14-year-old children. In the analytical type of cross-sectional study, you may try to further look into details. For example, this study may be used to investigate the association between a putative risk factor and a health outcome. However, this type of study is limited in its ability to draw valid conclusions about any association or possible causality, because the presence of risk factors and outcomes are measured simultaneously. It may therefore be difficult to work out whether the disease or the exposure came first, so causation should always be confirmed by more rigorous studies. The collection of information about risk factors is also retrospective, running the risk of recall bias. Next, we come to the analysis of cross-sectional studies. Any data that is collected must be processed and presented in a form in which it can be understood. In cross-sectional studies, the most common way in which we present the results is as prevalence. Prevalence is the count of both new and existing cases, whereas incidence is the count of new cases only. Most cross-sectional studies present the prevalence, and some the incidence also. Let us look at an example of cross-sectional study and on how the data is presented. Now, this study is on blood pressure in a given population. Blood pressure can be divided into 4 classes. 1. Normotension. 2. Pre-hypertension. 3. Hypertension stage 1. And 4. Hypertension stage 2. Now, you record the blood pressure of the subjects who are recruited for this study and you divide them into one of these 4 classes. Also, the entire group that you have recruited may be divided on the basis of their age group. So, now you have data on groups based on their age group as well as on the blood pressure that is recorded. The prevalence of normotension or pre-hypertension, hypertension stage 1 or hypertension stage 2 is presented in the table. So, looking at this data, you can say which group, that is the 30 to 39-year-old group or the 40 to 49-year-old group have hypertension or not. So, like this, you can choose a problem that is relevant in your area of research and collect relevant data. For example, you can do studies on the occurrence of some deficiency disease like, say for example, folic acid deficiency, or you can do anemia and so on. Having looked into an example and understood how to conduct a cross-sectional study, let us look into the strengths of cross-sectional studies. Cross-sectional studies are relatively quick and easy to conduct. They can be conducted at a particular point of time and they do not require a long period of time or follow-up. The data on all variables are collected only once. No repetition is required. In a cross-sectional study, we are able to measure the prevalence for all factors under investigation. Multiple outcomes and exposures can also be studied in cross-sectional study. Cross-sectional studies can be used in assessing the burden of disease in a specified population and in planning and allocating health resources. Cross-sectional studies are good for descriptive analysis and for generating a hypothesis. Now, though cross-sectional studies have so many strengths, there are some weaknesses which we should also know. Cross-sectional studies are difficult to determine whether the outcome followed the exposure in time or exposure resulted from the outcome. Cross-sectional studies are not suitable for studying rare diseases or diseases with a short duration. As cross-sectional studies measure prevalence rather than incident cases, the data is etiology. They are unable to measure incidence. Association identified may be difficult to interpret. Also, they are susceptible to bias due to low response and misclassification due to recall bias. We shall now look into another type of study, the longitudinal study. As you can see, the longitudinal study is carried out over a long period of time. The subjects are followed over time with continuous or repeated monitoring of risk factors or health outcomes. Here, we examine associations between exposure to known or suspected causes of disease and subsequent morbidity or mortality. In the simplest design, a sample or cohort of subjects exposed to a risk factor is identified along with a sample of unexposed controls. The two groups are then followed up prospectively and the incidence of disease in each is measured. In nutritional epidemiology, the concept is that diet influences the occurrence of diseases. Here, the basic method used is to identify essential nutrients. One very simple and early example in the history of nutrition research is the observation that fresh fruits and vegetables could cure scurvy. This was investigated by Lind as early as in the year 1753. She found that a group of sailors on a sea voyage were suffering from a particular type of skin disease. And she realized that their food did not contain fresh fruits or vegetables as they were on sea. When these sailors were given fresh fruits and vegetables, particularly from citrus fruits, the source of vitamin C cured the symptom and they were healed of the disease. So, this shows that in the absence of a particular nutrient from a particular source of food caused the disease, and when it was restored in their diet, they were relieved of the symptoms and healed of the disease. Nutrition problems in the past were typical deficiency syndromes, like, for example, protein energy malnutrition among 3 to 6-year-old children, or iron deficiency anemia among adolescent girls or pregnant women, and goiter in those living in hilly regions. The nature of the problems were the high frequency among those with very low intake, a short latent period, and these could be observed within days and reversed within weeks. Contemporary nutritional epidemiology is more difficult to investigate. That is because the major diseases of Western civilization, like heart disease, cancer, osteoporosis, cataracts, stroke, diabetes, and congenital malformations occur. Now, these diseases are different from the deficiency diseases. That is because the nutritional problems of the present day have multiple causes like diet, genetic, occupational, psychosocial, and infectious factors. Also, levels of physical activity and behavioral characteristics influence the occurrence of the disease. Here, long latent periods and cumulative exposure over many years or relatively short exposure occurring many years before diagnosis is observed. Also, the current nutritional problems occur relatively in low frequency despite a substantial cumulative lifetime risk. Conditions are not readily reversible. Many result from excessive and or insufficient intake of dietary factors. Therefore, nutritional epidemiology today is highly complex. They need to be carried out in highly controlled conditions and also only by experts. In conclusion, I would like to say that cross-sectional studies are more easy to conduct than longitudinal studies, and studies on the deficiency diseases are more conclusive than those on the current nutritional problems. Hence, friends, I encourage you to embark on nutritional research, first trying with the cross-sectional study and then going on to more complicated and extensive studies like the longitudinal studies on the current nutritional problems. Thank you.